finding out if a point is on a line. So our example here is decide if the points 1, 3 and -2, -5 are on the line of the graph of y equals 3x plus 1. Now to talk about this question, I'm going to graph the line, but you don't need to do that. I'm going to graph the line because it helps us see how the solution works, but the solution is much easier than graphing the line. But we could always use some practice graphing a line. So if I want to graph a line, you'll remember I draw a table of values, and always make sure you've got x is 0, and then a couple more points like that. And there's our table of values. Now, practice graphing a line. If x is 0, 3 times 0, well, let's do 3 times 0 plus 1. So it's 1, quite obviously. It's fine to use a calculator to graph a line. When x is 1, that would be 3 times 1 plus 1, that's 4. When x is 2, 3 times 2 plus 1, 7. And we could do this in our head, of course. 3 times 3 is 9, plus 1 is 10. So we've made a table of values, and we plot the points. 0, 1, 1, 4. Now I don't have enough space to plot all the points on this, but that's okay because I've got 2 points, and I can very carefully join them up, filling up the whole number plane, put arrows on either end, and label it with the rule y equals 3x plus 1. So we've graphed that line. Now obviously, if I want to know if these 2 points are on that line, I can just plot the points. 1, 3 is not on the line. -2, -5 is on the line. But we don't have to graph the line to find that out. What we can do instead is look at our table of values. The first point, 1, 3, when x is 1, it's saying it needs y to be 3. But y is 4. We know that from the table of values. So we can circle that on the table of values and say 1, 3 is not on the line. Now we didn't make the table of values big enough to have the -2 in it. We could have just made the table of values big enough to have -2 and -1 and the x as well. And when we did that, let's put a -2 in. Let's just sneak it in over here as if it was already there. We'd use our calculator because it's 3 times -2 plus 1. 3 times, use the negative key, -2 plus 1, -5. That tells me that because this point is in the table of values, it must be, oh sorry about going crooked, it must be on the line. So you don't have to graph it to know. The table of values tells you everything you need to know, but you would have to make sure that the x value from each of the points was in your table of values. Circle it. If it's the correct point, like this one, it's on the line. If it's an incorrect point, like this one, it's not on the line. Now there's a different way to do it if you prefer. If we'd got to this point and gone, oh, we didn't put it in the table of values, then what you can do instead, when I was trying to work out if -2, -5 was on the line, is you can write the rule y equals 3x plus 1 and take that value of -2 and substitute it in here. 3 times -2 plus 1. Use the calculator the way we did. 3 times -2 plus 1, -5. And if that comes out to be this, then yes. So we would say, yes, the point is on the line. So you've got two options for how you do this question. I wouldn't ever graph it. That's just showing you what the question's asking. You can do a full table of values, making sure you've got the right x values to check the points. Or you can do working for the x value and say yes or no. It's up to you.